Hello, my name is Smitesh and welcome back to my YouTube channel. Managing memory using raw pointer in C++ is quite a difficult task. We always have to track allocation and deallocation of the memory. If we forgot to deallocate memory, this results in a memory leak. And if we are not sure whether we have deallocated or not, we sometimes try to deallocate again. This can be a crash. Sometimes our pointers pointing to a memory location which has been already deleted. So using raw pointers, we may have such kind of issues. So how can we resolve these issues? In this video, I will try to walk you one of the best method where we can resolve all these issues. So let's get started. Let's first discuss few problems of raw pointers in C++. The first problem is the memory leak. That means when we dynamically allocated memory which is not properly deallocated, that is called a memory leak. So if you see in this code snippet, there is a class called employee. It has few member variables and it has constructor, destructor and one method print. In the main, we are creating object dynamically using new operator. That means memory has been allocated dynamically. And here we haven't deallocated this memory. That means the memory which has been allocated will never be deallocated. This is called a memory leak. The another problem is dangling pointer. That means our pointer is pointing to a memory location which has been already deleted. So this is the same example, same class. We here first creating object dynamically. We create object dynamically, then we delete, and then still we are using that deleted pointer to perform some action. This is really a problem. This is called a dangling pointer. Now another issue is ownership ambiguity. So if you see this code, we create object dynamically here pointer with p John. This pointer or this object we initialize to another pointer like pj. That means p John and pj both are referring to the same memory location. If then we delete this p John, that means we delete this p John, that means the we allocated memory that has been deallocated, and at some point we still trying to deallocate this pj object. This is a problem, right? Because here we are not sure whether we are owning a memory reference or not. This is called ownership ambiguity. We are not sure or we are not confident that whether this pj holding a valid memory reference or not, and this is called the double deletion issues also. So how all these issues using raw pointers can be solved in modern C++? In modern C++, there is a concept called smart pointers. When we use smart pointers, all these issues resolves easily. So let's discuss first about smart pointers. We will first understand what is a smart pointer and what is the logic behind smart pointer. So in this definition, smart pointers are objects that hold raw pointers with additional functionality. Now let's understand this. Consider this is a function or method and this is a smart pointer, and this smart pointer hold a raw pointer. Now when the scope of this smart pointer goes out of scope, means out of this function scope, it deallocate memory which is held by this raw pointer. This is the logic of the smart pointer. It may have some additional functionality that we'll see later, but this is the main logic behind the smart pointer. It holding a raw pointer, and when the smart pointer's scope goes out of scope, it release memory held by a raw pointer. So smart pointer automatically manage the lifetime of dynamically allocated memory. We'll understand this using this example. Now consider this example man. It contains a raw pointer, and the raw pointer, the object is created dynamically in this raw pointer, and we have one of the smart pointers called unique pointer. We will discuss later. And we here also we create object of the employee class. Here also we are creating object of the employee class using new, and here also using unique pointer. Now when this program, when we run this program and it finishes, so what happened, this ptr hold a memory reference, right? So it will never deallocate because we haven't explicitly called delete or deallocation logic. But if you see this smart pointer, when it goes out of scope after this man, it will automatically deallocate memory which is held by p zones. That means the it is automatically delete the pointers which is held by this p zones. So with this we have a lot of benefits. We can reduce the risk of memory leak. In this condition we get a memory leak, right? Because we haven't explicitly delete pointers, while here it will automatically delete. So with the smart pointer we can reduce the risk of memory leak. Dangling pointer means the pointer which is still pointing to the memory location which has been deleted. In this case this will not happen. And double deletion, this problem will also solve. We'll see this in later in the coding. There are three types of smart pointers. First is unique pointer, shared pointer, and weak pointers. In this video we will learn about unique pointer. Now let's understand what is unique pointer. Unique pointer is one of the smart pointers. The speciality about unique pointer is that at a time only one unique pointer object hold a ownership of a dynamically allocated resource and is responsible for automatically deallocating the resource when the unique pointer goes out of scope. Let's understand this statement with the help of this example. So in this main we create object of unique pointer. This unique pointer hold a memory reference of this employee. Now when this pjohn object goes out of scope, it will automatically deallocate the memory. Now the second statement is the ownership cannot be copied but transferred using std move. So when we perform this assignment kind of thing, like we are copying this pjohn to pj, this will not allowed because we here mentioned that only one unique pointer object hold the ownership. That means only pjohn hold the ownership of this memory location. We cannot copy this memory location, this pjohn, to another unique pointer. We can perform transfer, we can transfer the ownership. We will see when we do coding on unique pointer. So this will give the compilation error. Now why should we use unique pointer? First reason is it automatically deallocate the memory. That means all the problems that we were facing using raw pointer, like memory leak, dangling pointer, that will resolve using unique pointer. The main advantage is also is that one more advantage is also is that only one unique pointer hold a memory reference or ownership. Only one unique pointer hold ownership of the memory location. There is no two unique pointer that pointing to the one memory location. That is not possible in case of unique pointer. So we can easily say that when we use the unique pointer, that pointer is only holding the memory location or ownership, that only the ownership of the memory location. This is a benefit of using a unique pointer. So let's do coding and how we can create a unique pointer object and how we can perform certain operations using unique pointer. Let's see in the coding. Let's see unique pointer in coding. To use unique pointer, we need to include header file, memory, and unique pointer reside in standard namespace. So we declare here using namespace std. Now this is an employee class. This is the same employee class that we saw in presentation. It has three member variable: employee ID, employee name, and salary, and default constructor, parameterized constructor, destructor, and print method. This print method just printing their member variables. Now there are two methods to create unique pointer. So let's use first method called direct initialization. So unique unique ptr employee, and I am writing name p john. As this is a direct initialization, we create object directly employee and use parameterized constructor 1001 John and his salary 1500. Okay, now we call method print. So p john, okay, spelling mistake, john, p john, and print. And let's see, we build the solution, and as we can see here, we create employee object with the name John, employee ID 1001, and salary 1500. So it called first constructor. This called the constructor, that means p john pointing to object of employee John, and this John, when we print, we can see all the elements here. Now when this p john goes out of scope, that means after this it will automatically deallocate a memory. We can see here destructor 1001, it is called. So here we are not explicitly deleting or deallocating memory. This unique pointer use some logic to deallocate memory created by this pigeon. Okay. Now we will use another method, that is a recommended method to create unique pointer. The method name is make unique. So let's use that. Unique pointer employee, same variable I am keeping, make unique, and employee, and giving parameterized constructor 1001, same John, and salary 1500, and we call print method p john print method. And when we run, first we build, the same output we can see there. See here, first constructor called and this print method print all the elements or all the member variables value. And when this pigeon goes out of scope, it releases the memory and call the destructor, this destructor. So we generally, when you used unique pointer, make sure you use make unique method to create a unique pointer. This is a recommended method to create a unique pointer object. Now we discuss, at a time unique pointer has only one owner of the memory reference or the memory variable object that is pointing to. So that, what does this mean? P John is the right now current owner of this employee. We cannot have a two employee. Let's start creating two owner of the owner of this object. So what we do, we create a unique pointer employee. Here I am writing P and I am sharing my ownership with P. That means P John is sharing ownership with P. But this gives the compilation error, because as per the rule of the unique pointer, only one owner should be used as a owner. Only one owner of the unique pointer hold the memory reference or the that point to the memory. So here P John only. P John cannot share his ownership with P. So this will not work. But if P John pointer or variable want to share, or P John want to transfer his ownership with another pointer, another unique pointer, it is possible. So unique pointer, let's say I am writing P and my transferring I am transferring ownership to P. So std and move P John. So this is allowed, right? Now P John is transferring its ownership to P, and when we call P to print, it will print all these values, and this P John will be a null. Let's see. Building and calling here. If you see, this constructor is for this one, make unique. Then this P John transfer its ownership to P. That means we are getting again this ID, John, and salary information for this P. But now P John is holding nothing, because at a time only one unique pointer hold the ownership. So you can transfer the ownership using std move method. So now when this P goes out of the scope here, it will call destructor. That means it releases the memory. Now another method, that is a reset method. The purpose of reset method is to release the hold object or held object, to release the held object and mark it to the null, or you can create a new object on the fly. Let's see both cases. So right now this P is holding object of this 1001 John and 1500 salary, right? So when we do P release reset, it destroy this object and mark it to the null. Let's see. We write here let's run this program. Now if you see this constructor, that is means this one make unique id, then it transfer its ownership to p here, transfer ownership to the p here, and when we do reset, this p reset, it deallocating memory, that means it's cleaning the object, that means destructor is called, and this message is printing after this. So this is the way we can reset the pointer. Now if we want, if we want to while resetting, if we want to initialize a new object, that also possible. So instead of using, we can use a reset and directly we can create a new object, employee. Let's say I am giving 202 Maya and her salary is 1500, 2000. So we can see here destructor of the pigeon and constructor of the Maya. Let's run. So this is a unique pointer. This first one is for the make unique, then its print method, then its ownership here. Now we are resetting this p, so it first call the constructor for this Maya and then remove the previous object that is held by, that means this John is removed, and this after print method is showing after reset method, and again when this p goes out of the scope, it calls the destructor for this Maya. We can see here. If you want to print all the member variable, we can print here. We can see the value of all the member variables. Let's we don't want to print this. Now if you see, this is a constructor, this is a first constructor, then this is a second constructor, this Maya constructor, then it releases this John 1001, then it's printing this print id, Maya and salary, then this after reset, and when this p goes out of the scope here, it releases the memory of this Maya object. We can see here the destructor. Now release. Unique pointer has one more method, release. Release, what happens, sometimes we want a raw pointer, and because as I mentioned, a smart pointer contains raw pointer, it holds the raw pointer, so sometimes we need that raw pointer, but we don't want to destroy, we don't want to deallocate the memory. We will deallocate by own, means we will explicitly deallocate the memory. So when we have such kind of requirement, release method can help us. Let's see, p dot release. If we call this release method, we can see what is the return value. You can see it returns the raw pointer, but it will not call the destructor. We will see. T. Okay. Now it is now our responsibility to deallocate this T, because as I mentioned, release will not perform any deallocation. It is the responsibility of the caller to call the deletion method or to deallocate the memory. So we have to explicitly write this delete statement. If we do not write this delete statement, it can cause a memory leak also. So when you use a release method, use wisely. Now I am not calling this delete method, and let's see what is the output. You can see here constructor destructor of the John, then print method, and this after, but there is no destructor called, because this is the nature of the release method. It will not release the memory. Now we have to release explicitly. Even if this p is go out of the scope, there also it will not release the memory. If we write this delete statement, we can remove the memory leak problem. Look, destructor has been called. Okay. Now the last method, that is how can we create array of unique pointer. How can we create array of object in unique pointer? So consider I have a unique pointer, and I want to create array of employee emp array, and I am using make unique. Okay, employee array, and here we need to place how many number of elements we want to create. So let's say I want to create 3 elements, so I am entering 3. Now we can create object one by one. 0, then employee 1001, then Maya 3000, employee array 1, employee 1002, Shina 3500, P 2, employee 1003, and Peter, and let's say he earned 4000. So this is a way we can create array of object in unique pointer. So that's it for unique pointer encoding. If you like this video, then support me, do a like button and subscribe my channel. Thank you.